Hi everyone. So we're going to be doing 2 more lessons this week, lesson 1, lesson 2. And our first lesson is about classifying triangles. So we're going to do the first half of lesson 1 today and then finish it tomorrow. So you guys have heard of acute, obtuse, right, and then 3 congruent angles. Hopefully you have at least heard of that. 3 acute angles means smaller than 90. All of these angles are smaller than 90, so we call it an acute triangle. There only has to be one obtuse angle. Actually, there only can be one obtuse angle in a triangle to call it an obtuse triangle. One right angle to call it a right triangle. And then if you have, remember, all of these lines indicate that the angles are congruent. So here, 3 congruent angles is called an equiangular triangle. I don't even know if I'm saying that right. So those are the 4 types of triangles. So it says classify each triangle in the diagram below by its angles. So if we're looking at triangle CDE, okay, CDE is this, right? We see the right angle, so it's going to be right triangle. Sorry if you can hear my pencil on this iPad. Okay, BCE. I try to be as quiet as possible with this. BCE is obtuse because BCE here, this angle is obtuse. So obtuse, I'm just going to write obtuse triangle like that. ABE, okay, this is going to be the one I can't say. Equiangular triangle. Angular triangle. Because they're all congruent angles. BDE. Okay, we see an obtuse angle right here as well, this obtuse. So obtuse triangle. And then CFE. CFE is acute. We can't say they're all equal because they need to have these to indicate that the angles are equal. So we'll just call it an acute triangle. Okay, 3 congruent sides means equilateral triangle. 2 congruent sides, isosceles. This is how we label congruent for angles. This up here is how we label congruent. This is how we label congruent for sides. This is how we label congruent for angles, okay? So this right here means all 3 sides are equal. Here means 2 sides are equal, which is isosceles. No congruent sides is called a scalene triangle. So now it's asking to classify the diagram by the sides. So JKM is this entire triangle. JKM is going to be scalene. We don't see any of the same sides. So I'm going to say scalene. You'll see the difference here in a second. Because KLN, do you see how that, okay, that means this side and this side are equal because both of them have 2 dash marks. So if 2 sides are equal, and that means this is a separate side, okay, because it just has 1 mark. So that means isosceles triangle. Isosceles, and I guess I should say triangle. And then JKN, do you see how there's 3 dash marks and they're all only 1 dash mark? So that is equilateral. Equilateral triangle. Classify each triangle by its angle and sides. Okay, so this time we're doing it by its angle and sides. Remember these were angle, sides. Okay, so angle would be right because it has a right angle. And it has 2 congruent sides here. So remember 2 congruent sides here would mean isosceles triangle. So right isosceles triangle. Okay, angles here. So if we go back to the top here, remember if one angle here is obtuse, anything greater than 90, it's an obtuse triangle. And then it doesn't have any equal sides, so scalene. And then here, all the sides and all of the angles are congruent, so it's oh gosh, okay, it's going to be an equiangular equilateral triangle. Equiangular equilateral. Whoever comes up with these names, I have no idea. Okay, so we're halfway done with the notes. Now, on the second page, oh, okay, I'm pretty sure you guys get this, but on this one, this doesn't have any congruent angles here, but all angles look like they are less than 90, so acute. And all sides are different, so scalene. This is right, scalene, and obtuse because 97 is greater than 90. Isosceles because both of these sides are 5, right? So that means that they're equal. Sorry, I know that was fast, but you guys probably understand that. Okay, if PR, okay, do you remember what the word bisects means? Bisects means splits into two equal angles. So if PR bisects angle SRT, okay, so let's look what that even means here. If PR, okay, this whole line bisects SRT. So this line splits this angle into two equal pieces. That means if this is 30, this is 30 also. So let me write 30 in here. Because bisects means that that will also be 30 degrees. And U is the midpoint of RT. U is the midpoint of RT. Okay, that means they equal each other. That means that this, since this has a dash, I'm going to also give this a dash because those two are equal. And because this one and this one were automatically equal, that means all three of these are equal now. That makes sense? Because it says that U bisect TR, so now both of these are equal. Classify each triangle by its angle and its sides. Okay, UQR. UQR is here. Okay, so 120 degrees would mean it's obtuse, and it has two equal sides, so isosceles. Obtuse, isosceles triangle. RST is here. RST. Okay, see how that was 30 and 30? That means this whole angle here, the whole thing is 60. This is 60. This is 60. We can say that this whole angle is 60 because 30 plus 30 is 60, okay? So if we're talking about RST, we're talking about this entire angle, not just half of it, right? We're talking about from here to here. So that whole thing is 60. So all three are 60, which means equal, oh yeah, okay, so equiangular, and equilateral. Equilateral. Oh my gosh, sorry guys. I'm not a speller. This is a lot. Okay, so here, this is how I knew it was equilateral. This is 16, this is 8, and this is 8 because those two are equal. And this is 8, and this is 8. So that's 16, this is 16, this is 16, which means all three sides are the same. Okay, SRQ. SRQ is right, and none of the sides are the same because we don't know what this line is here. It doesn't tell us. So that automatically means we don't know enough information. So we're just going to say right scalene. And then PRT. PRT is this. So this is 16 and this is 16, right? So two sides are the same, so it's isosceles. And this is going to be obtuse, right? It looks like an obtuse. It's greater, 90 would be straight up and down like this, be a right angle. So that's obtuse, isosceles, TQU, right here. Okay, so that's going to be equilateral and equiangular again. Because if this is, see how this is 120? The whole thing is 180, isn't it? Because it makes a straight line. A straight line is 180, which means this also has to be 60. And that means this has to be 60 because 60 plus 60 plus 60 is 180, and a triangle has to add up to 180, right? So we know it's going to be equiangular, equilateral triangle. Okay, PQT is right and scalene. That was here, PQT. So it's right angle, because remember vertical angles, that means if this, see how everything ties together here? This and this are going to be vertical angles. So if one's 90, the other has to be 90. And it's a right triangle and scalene because none of the sides are the same. Okay, last three, but this is kind of a lot of work. So hopefully we understand this. I wonder how many of you are still listening to me. I hope everyone is. But okay, here we go. Distance formula. Distance formula is here. You guys are amazing, and I appreciate you. And we're almost done with the semester, and you guys have done so well. So go ahead and write this down. And we're going to use that. Okay, so we're going to use this formula. I had to stop the video because I did the next two problems, and I messed up on one of them. And I don't know how to go back and change it. And I knew I messed up, I just didn't know where. So I had to go back. So let's do this. So go ahead and write the distance formula down. And then essentially what we're doing is we're finding the measures of the side JKL. Okay, so we don't know what this triangle looks like. I'm going to draw something. I'm just going to draw JKL like this, okay? A very simple, regular looking triangle, right? What we're trying to do is we're trying to find the distance between J and K, between K and L, and between J and L, okay? So if this is what our triangle looked like, maybe I should move this over because I might need a little more space. And this is essentially what we're doing, okay? Just to have a visual of what we're doing, because I am such a visual person. I like seeing what we're talking about. So right now we're not pretending, but we're finding the distance between J and K, pretending it looks like this, because we don't know what the triangle looks like, okay? I'm just drawing out some random triangle. We're finding this distance right now. Okay, so let me label this x1, y1, x2, y2. So we're going to say x2 minus x1 squared plus y2 minus y1 squared. So x2 minus, so -9 minus -7 squared. I actually made a mistake right there, the very first step. And then y2 minus y1 squared. Okay, so square root of -9 plus 7 squared. Okay, we know how I am with math in my head. Not good. So hopefully I don't make any more mistakes. That's why I made a mistake, and I didn't even bring my calculator here again, which was definitely a mistake. 4 plus 64 is 68. Okay, so we're saying this is square root of 68. That's that distance, okay? We're going to find this distance now between K and L. KL. So KL. And I'm going to erase this now because now I want my K and L to have x1, y1, x2, y2, and I'm going to do x2 minus x1. So -1 minus -9 squared plus -1 minus 1 squared equals square root of. Okay, so that's going to be 8 squared. By the way, if you're smart, unlike me, you can just plug all this in your calculator, which would be way faster. 64 plus 4 is 68. Oh, good. That means I did the math right. Okay, so that means that this is going to be 68. Whoa, I don't know what that is. Hang on. Square root of 68. And then JL is the last one. I know this is tedious, but it's not hard. It's just a lot of work. So let's try. Last one is J and L. It doesn't matter which one you label x1 and y1, by the way. Okay, so x2, -1 minus -7 squared plus negative 1 minus negative 7 squared. Add here, because two negatives make a positive. That's going to be 6 squared plus 6 squared, which is going to be 36 plus 36 is 72. Okay, so that means JL is 72. Now, according to this, two of the sides are equal. If two are equal, we call that isosceles triangle. So because now if all three of the sides were equal, we call it equilateral. And if none of the sides were equal, like if this was 68, 55, and 72, let's just say, then it would be scalene. Okay, so I'm actually not going to do the next two because I think hopefully this makes sense to you. You just use the distance formula. That's all you're doing is you're using the distance formula and plugging this in. If you don't understand how to do this, I will definitely help you tomorrow. But try these, or I guess you don't have to try 22 and 23, but just see how you feel, and then we'll do some practice.